This is Chapter 2-4, Reasoning with Properties from Algebra. Please copy your codes. To begin, we're really now getting into proof writing. That's what Chapter 2-4 deals with. Understanding how to write proofs means you must go home, stay at home, be in your book, study postulates and theorems and properties. You have got to remember them. Like you know the Pythagorean theorem, a squared plus b squared is equal to c squared. All new postulates, theorems, properties, you have got to put to memory. You should know them without looking. I can't stress that enough. So once I give you a property or a theorem or a postulate, you have to study it. Let's start here at the top. We're going to let A, B, and C using variables be equal to real numbers. Here's the first property. Okay? This is the addition property of equality. For example, if I let A equal B, if A is the same as B in other words, then that means A plus C is going to still be equal to B plus C. A and B are the same, and apparently we're using the same C value. It will be the same. For example, if I have 2x, I can use this here. If I have 2x minus 3 equals 11, this is the addition prop. Because of this property, I can solve for x, where I add 3 to both sides. That's our C. Okay? I'm adding 3 to both sides, giving me 2x equals 8. Okay? You learned that back in Algebra 1. Okay? So the plus 3 would be the C. Because of this property, I'm not saying that 2x is the A, and I'm not saying that the 11 is the B. But I want you to focus on when I add the same thing to both sides of the equation, I have the addition property. And the same thing that I'm adding is the C. Add 3 to both sides keeps my equation balanced. Okay? And this is the addition property of equality because I'm adding 3 plus 3 to both sides. Even though it says 2x minus 3, I'm adding 3 to keep both sides of the equation balanced. So this is the addition property of equality. I'm adding 3 to both sides to keep the equation balanced. Similarly, as I stated before I even get to the next, the plus 3 on both sides of the equation is the C when dealing with algebra and proof writing, which we're getting ready to get into as I stated. Subtraction property is the same thing. Let's suppose if A is equal to B again. I know A and B are both 10. I don't know what A and B are. Just suppose they're the same. Then, notice the if-then statements, the conditional statements. If A minus C is equal to B minus C, what I do to one side of the equation, I do to the other. So if I subtract C from the left side, I subtract C to the right side. This is subtraction property of equality. For example, 4x plus 5 is equal to 21. I'm going to balance and solve for x. If I want to solve for x, I'm going to subtract 5 on both sides of the equation to keep the left side equal or balanced to the right side. You learned that back in Algebra 1. Okay, for those of you that like it vertically written, 4x plus 5 equals 21. Again, to keep the equation balanced, I subtract 5 on both sides of the equation. Okay, and again I state, I'm not saying that the 4x is the A, and I'm not saying that the B is the 21. Okay, I just want you to focus on the fact that what I do to one side, I do to the other. In this case, what I'm doing to both sides is subtracting the C. This is the minus C here when I take away the 5. I want the right and the left side to be balanced. You learned that back in Algebra 1, balancing the side of the equation. So your C is the minus 5. All right, and here we have. So minus 5 on both sides of your equation is your C, should be on that far end over there when dealing with algebra and proof writing. Okay? And this should be, is your, over here in the corner should be C in parentheses. That's what that says right there. All right. Next property is the multiplication property of equality. Notice property of equality, equal. I'm trying to keep both sides of the equations equal. That's why I balance them. This particular case, if A is equal to B, then A times C is going to be equal to B times C. What I do to the left side of this equal sign must be also done to the right side. And on both sides this time, I'm multiplying the left and the right side by C. For example, if I have H over 4 is equal to 23, to solve for H, I need to get the 4 out of the denominator by multiplying the left and the right side, which is your C, by 4. So, getting the 4 out of the denominator, multiply the left side and the right side by 4. And H is going to be equal to 4 times 23. And I don't think I need to show that one too much further. Hopefully you get where I'm going. Division property of equality, same thing. Dividing both sides by the same number or the C. In this case, I say if A is equal to B, C cannot, in this particular case when I'm dealing with division property, C cannot equal 0. Then A divided by C will again be equal to B divided by C. So if I have 6R equals 72, to make this a division property of equality, I divide both sides by the 6 to drop the 6 over here on the left side and leave R. Okay? The C in this particular case, if you haven't discovered it, the C is dividing by the 6. Okay? Dividing by the 6 on both sides of the equation, the left and the right. Reflexive property. And again, I've listed 4 properties so far. You need to commit these to memory. Reflexive property of equality. For any real number of A is equal to itself. So $10 is $10. It's equal to itself. For example, if the measure of angle P is equal to the measure equal to P, that's going to be the reflexive property. I'm reflecting it back to itself. It's kind of like a mirror, holding a mirror to itself. So if the equal sign is the mirror, the left side exactly is the same as the right side. So reflexive, reflection, you can look at like almost like that, which we'll talk about reflections later, a little different. Okay, a little later. All right, so if I have 42 degrees, it's going to be equal to itself, 42 degrees. This is the reflexive property, equal to itself. Now, symmetry, okay, a flip, symmetrical property of equality. If A is equal to B, then B is equal to A. For example, if A is equal to 7, then B is equal to 7. So even if I flip it around, B will be equal to A, or B is equal to 7, A is equal to 7. They're both equal to one another. A equals B, B equals A. Symmetrical, they're the same thing. Transitive property of equality. I love this one. Transitive property of equality is if A equals B, and then B equals C, what does that mean? If A and B are equal, and B and C are equal, what is that saying about A and C? They too must be equal. So A is equal to B, then B is equal to C. That means that A also must be equal to C. All right, and here we have, if segment MJ is equal to TW, and segment TW is equal to RH, then that means that, let me say that again, if segment MJ is equal to segment TW, and we also know that TW is equal to RH, another different segment, that means that MJ and RH have to be equal to one another. So then MJ is equal to RH. All 3 segments are congruent. So I have a segment here, here, and here. And if this is MJ, and this is, I don't like that. If I have a segment here, MJ, have another segment here, TW, and I have another segment, RH. If MJ is equal to TW, and TW is equal to RH, that means that MJ will be equal to RH. All three will be congruent to one another. That's transitive property. If I know these two are congruent, the first and second, and I know the second and third are congruent, that means that the first and third will also be equal to one another as well. Okay? All right, example, if A is equal to 5 and B is equal to 5, and A is equal to B, so that means 5 equals 5. And if B is equal to C, and B is still equal to 5, then C is also 5, meaning A and C are 5 equals 5, or congruent to one another. Make sure you take a second and get that copy. Next, we have substitution property. Substitution property of equality. If TJ, segment TJ is 4 centimeters, and segment EW is equal to 15 minus TJ, then you should be able to substitute 4 in for TJ, because we just said that segment TJ is equal to 4 centimeters. And again, then EW is equal to 11. Why? Because we substituted. Because we know that TJ is 4 centimeters, and take this 4 centimeters and put it in for TJ. I'm substituting. Instead of saying TJ, I'm now going to say 4. This is substitution when I put something in place of something else. Something in place of something else. Okay? And how do we do that? If A is equal to B, then A can be substituted in for B any other place in the equation, which we just did. Okay? If this is A and this is B, for example, TJ represents your A, and this is your B. A equals B. When I get over here to this equation, segment EW equals 15 minus TJ. 15 minus the A here. Well, A is the TJ. I haven't solved for anything, but I see that A and B are the same. Instead of saying B, or A, excuse me, instead of saying A, I can now say B, which is the 4. So 15 minus 4, which is where we get the 11, from where we get the 11. All right, we're going to continue this lesson on tomorrow.